Every single time you open an app on your phone, you're tapping into this hidden world. It's like a massive, complex backstage that just makes everything look simple. But what's really going on under the hood? Well, today we're going to pull back that curtain and take a look at the fundamentals of cloud network security. All right, let's just dive right in. This whole idea, it really clicked for a developer who was working on what seemed like a pretty simple cloud project. And they just stumbled upon this surprising truth about the internet that, we all use every single day. And this quote, man, it just captures it perfectly. There's so much complexity behind the scenes. Behind every single click you make, there's this intricate dance of rules and gateways and security checks. So our goal today, we're going to demystify that complexity, one piece at a time. So the big question is, how do we manage all this chaos, right? Well, you start by carving out your own private, secure corner of the internet. And that, my friends, is where something called the Virtual Private Cloud, or VPC, comes into play. Okay, imagine the entire cloud is just this vast, endless ocean. A VPC, well, that's like your own private island right in the middle of it. It's this completely isolated space where you are in charge of everything. You control the layout, you control the security, and you decide who gets a boat to the shore and who gets turned away. Now, having a private island is awesome for security, right? But you can't be completely cut off from the world. You need to send and receive stuff, information. So how does data know where to go? How does it navigate the roads on your island? And how does it find its way to the wider internet? Well, that is where route tables come in. Sticking with our island analogy, if the VPC is the island, then route tables are basically the road signs and the GPS system all rolled into one. They give every little packet of data a crystal clear set of instructions on exactly which path to take to get where it's going. So here's how it works in the real world. Let's say something on your island wants to connect to the outside world. That data first hits the route table. The table looks at the destination and says, hey, this isn't on the island. So it looks for the everything else rule, the one that basically says send all other traffic here. And then it sends that traffic straight to its target, the internet gateway. Think of that as the one official port, the harbor that connects your private island to the vast ocean of the internet. Okay, so we've built our islands, we've put up all the road signs, but wait a minute, what about security? I mean, who's checking IDs at the door? Well, in the cloud, you've got two critical layers of security that act like bouncers for your resources. And the difference between them is absolutely key. First, you have a security group. This is like a key card for a specific building on your island. It decides who gets to enter one particular server. Then you have a network access control list, or a NACL. This is way bigger. It's like the border patrol for the entire island. It controls traffic for a whole neighborhood, what we call a subnet. So you've got two different layers of security, and both are totally essential. So let's break down a security group. It has two sets of rules. First, there are inbound rules. These control what's allowed in. And listen to this. By default, everything is denied. You have to literally, explicitly open the door for specific things, like web traffic. Then you have outbound rules, which control what's allowed to go out. And here, by default, everything is allowed. It's kind of a trust but verify approach. And this is where you can really see the difference with the network ACLs. A default NACL, the one you get out of the box, it starts wide open. It lets all traffic, both in and out, just flow through. But if you create a custom one, it's the total opposite. It starts completely locked down, denying everything by default. This is what you'd use for your most sensitive systems to make absolutely sure that only very specific, pre-approved traffic ever gets close. Okay, so we've got a handle on how to secure one private island. That's great. But what happens when you're a huge global company? You don't just have one island. You have an entire archipelago, a whole chain of islands spread all over the world. How on earth do you manage that? I mean, just imagine this really scary but very real scenario. What happens if your entire cloud region, say the whole US East Coast operation, just goes dark? If all your servers, all your data, everything is in that one spot, you are completely offline. Game over. This is exactly why a multi-region strategy is so crucial. Big organizations create basically identical setups in totally different parts of the world. That way, if the US East region fails, all the traffic can be automatically rerouted to, say, the US West region. And here's the magic part. For you, the user, nothing changes. the app just keeps working. It's all about ensuring high availability and fault tolerance. But as you can probably imagine, trying to manage all your stuff across all those different regions can be a total nightmare. I mean, in the old days, you'd have to manually log in to each and every region just to see what was going on. It was a huge pain. And that's exactly why a tool like EC2 Global View is such a game changer. And the benefit is just immediate. EC2 Global View gives you what we call a single pane of glass, one dashboard, where you can see, search, and monitor all of your resources everywhere on the planet all at once. No more clicking around, switching between regions. It just transforms this incredibly complex, time-sucking task into something simple and efficient. All right, so we've gone on quite a journey here, right? We started with one single, complex project, and now we're looking at a secure global network. We've uncovered the core pieces that make it all tick. So let's do a quick recap of what we found. You've basically got the mental model now. You understand that behind every app is a private VPC sandbox. The data flowing around is guided by those route table road signs, and all the access is controlled by our two bouncers, the security group, who's the bouncer at the specific building's door, and the network ACL, who's the border patrol for the whole area. It's like, with this new knowledge, you've gained a kind of X-ray vision for the digital world. Seriously. So the next time you tap an icon on your phone, just pause for a second. Think about that invisible network that just sprang to life. The private islands, the digital traffic cops, the security guards, all of it, working in perfect concert just for you. My question for you is, what else do you see now that was hidden before?